Welcome to video number 3 in the Composite ARF or CARF Rebel Hot RC Jet build series. This is going to wrap up in this video, video number 3, final setup of all the equipment, final installation of all the equipment. We got to test run the engine, we got to CG the plane, a lot to do, so let's get busy. Last video we wrapped up with finishing up our board and our power system for the electronics. So that portion is completed. We've got a couple other little odds and ends to tie up here, but this is going together very well. Now there's a couple choices we have at this point here. We can start running our leads to the various items, which isn't a bad thing to do because we have our primary receiver going into Cortex. We can get our Cortex programmed. We could plug in our gear and brake channels to the electron controllers and get that kind of stuff finalized, which is always a good thing to do at this point. So I think that's the next thing we're going to do. And that's why I keep my little cutoffs as well too, because these little sections of wire are perfect for going in between the various items, and that's what I use to make up my small little leads. We've got our fuel pump mounted. I just countersunk some screws in the bottom, so because there's the cross member going across there. And I've got my one output coming to my Cortex. Now, if you're using a central box, you're going to program the Cortex a little bit different. If you're using this type of setup where you're using servos into the Cortex, basically you go in and E1 needs to be changed to an EX bus port, and you go directly into B when you learn this. So you go into B, you turn the system on, put your programming plug in, let it recognize the receiver, unplug it, plug it back in, go through the setup process with your stick movements, and then you're good to go. If you're using the Cortex and you're using an EX bus setup through the central box, you'd go in port A to learn it, and then you move it to port B when you do your stick movements. So there's a small little change there with how you set things up. It's fairly straightforward though. On if you read the big manual, it shows you all that stuff. So yeah, so that's all programmed there. So now what we're going to do is we're going to run our leads from our receiver into our gear controller. So our basic wiring is done here. So we've got our receiver primary going into our Cortex in B. We've got a secondary power supply that's coming from port number 12 on our primary receiver, which is our gyro sense port. So that's not really functionally doing anything other than working in the radio system, but that's just providing an extra power supply. We've got a test servo plugged into our Cortex right now, and then we've got port 10, which goes to our gear input on our controller, port 11, which goes to our brake input, and nice short wire lead. So that portion is done. That's all the stuff that goes in between everything on the board. Now what we want to do, and we've got our 900, that's bound and working to the system. That's plugged into E2 on the primary receiver. So what we'll do is we're going to go into our advanced properties, wireless modes trainer. We're going to come in here and we're going to disable the primary module. So TX1 or primary module is disabled, and now we're just running on the 900. And with the 900 active, our servo still works. And we'll turn back on to our regular system, and we're all good to go. So we've confirmed that works. That's great. And this board is... So we doing a little bit of cleanup here. So we've got our pitot tube mounted. Very simple. Just drilled this out. Now the stock pipe that goes up to your canopy pin comes up at an angle. So when you drill this for the pitot tube, you want to drill it in the center line of the aircraft. So we did that. That's all mounted in place with CA. Put a little bit on the outside here and then dripped it through the inside with kicker. So that part's done. We do still have to do our latch. The latch is going to be a challenge because getting something in here to sand down the gob of high sol or whatever it is going to be an issue. On the bigger Rebels, you could just put your Dremel in there, so I need to figure that part out. And cut the line for the front gear, put a clip in here or a connector, so if you want to take the gear out, you'll be able to do that no problem. So that's just up top here with a little bit of CA, and that line's going to run back to the board. We also got all of our labels done up. These are done up with our label maker that prints on shrink tube. So it is basically the kind of the basic rundown for all the surfaces and all the items that'll plug into the control board. All right, so we got all of our servo leads done up here. So we ended up shortening most of these a little bit, but they're all done. So we've got our 3 coming from the back. We've got all our ones coming from the wing, and they're all labeled as well too, so we know exactly where they're going to go. So that part's done. Now I've been procrastinating a little bit on the hatch. So we got the pitot tube installed, that's fine. Problem is getting in here. So there's a lump of high sol in there. I don't know if I'd be able to show you guys, probably not. But yeah, it's probably about that tall. And you can feel it. It's like the size of a penny, basically, or a dime right in that area. Anyways, on the larger Rebels, you can get your Dremel in there and you can sand that out, which is fine. This one obviously is a bit of a challenge. So I think, though, I've been thinking about this. If we retract that nose gear, I think we can use our flexible Dremel extension and bring it in here and be able to sand that down. So that's what I'm going to try. So we need to use our manual controller with our gear end here, get that gear retracted and see if that gives us proper access. If it doesn't, we may need to pull that gear out. All right, so I'll take you through the steps of our hatch latch here. Now, our Dremel, this worked out perfect. So this was able to go through the gear opening with the gear up, and it was just at the right angle to sand this down. Now, I used my aggressive carbide bit, so I was very careful and did this very slowly, kept feeling in here, you know, a little bit more until we were good. All the fiberglass is still there, we just got rid of all the glue. So definitely a challenge, but that part is done. So you're basically using the same hole here and the same hole in the canopy. All you're doing is replacing that metal pin that used to come through here with the hatch latch. So this is probably the most important part. So what I do is I take my white marker and my paint marker. You want to go about 1/4 of an inch away from the hatch here. This is exactly the same on the larger Rebels. And drilled out some holes and then used a pin file, the really small one, to sand that guy out. Then what you have to do is you have to take a BVM hatch latch and you really got to sand this thing down a ton. The reason you have to sand it down is because you want it to tuck in as tight as it can to this corner. And then also this plane being so small, it's got quite a bit of an angle to it. So you can see there, we have sanded a whole bunch of this hatch latch off. But ultimately the goal is when this is pushed up all the way forward, the back end is sitting against the fiberglass. So that's what we're after. Obviously we want as much pin protruding through as possible so we get good contact with our canopy, and that should work beautiful. So what we can do now is we can take a couple drops of CA. I'll lube the spring first, but I'm going to take a couple drops of CA, probably drill a couple holes in there to replace the ones that we sanded out. A couple drops of CA, get this thing tacked in place, and then we will see how it operates. Once we're happy with it, then we'll come in here and put some high sol on the latch, and then we'll let that cure and we should be good. So we got that tacked in place, put the canopy on, and that works perfect. So nice and solid, no movement there at all. That's great. And I love mine being set up like this with the pitot tube. I think it works awesome. So, and then getting it off. I am being quite careful with this because again, it's just spot glued with CA, but we just slide that forward and canopy slides forward. There we go. So now we'll mix up some high sol and we will glue this in place permanently. Just have to be careful you don't get any in the actual mechanism, but this airplane's a little bit difficult obviously because of the size, and that's where something like a lit up mirror comes in handy. So now I can use this, put my doctor hat on, and get our high sol installed there. So we've got our SPO6 switch out. Our instructions are here. Now the instructions aren't very clear. I struggled with this the first time I used it, but I'll show you on the actual unit how it lays out. So this is the SPO6 switch. It is essentially Just a simple on-off switch. Works with any radio system. It's not Jetty specific, so it's just taking a channel and it turns it on and off. So in this case on the radio, we're just going to set up another gear channel, and when we do gear down, the SP06 is going to turn on, and that's going to provide power for the lighting system. So the way this switch works is you've got power coming in on the red and black leads. The output side is the yellow leads, and those guys are corresponding, so red's on this side, and the yellow lead here you can see is marked as well. If you're pairing this up to like a channel that you can't reverse the channel, like let's say you're pairing it up to your one gear channel or one gear port on your receiver, you can take this little blue thing and reverse it, and that'll reverse the SP06 how it works. I'm not sure what the little dial gauge is for, but it says indicator on off set, so I don't really know what that's for, but anyways, they work just out of the package the way they are. So now this is going to feed our Cashel Creations BEC. The BEC here has been programmed to 4.8 volts because that is all those Sky Candy lights need, and that BEC plugs into the electronics of the Sky Candy light, and that lead goes forward nice and hidden in our gear, and it's also wrapped with spiral wrap to that point right there, so it's protected as that moves up and down. So that's our lighting system. Now this is going to pair up with the turbine is how we're going to do it. So I'm going to simply have this patched into the turbine plug-in, and the turbine battery is going to feed this and also the turbine. So because of that, we kind of need to figure out where our data relay module is going. Now because with this unit we've got the light version, so this is the version without a screen or anything, so this requires the separate data port thing, which is great because this is a nice light option. This can essentially be buried anywhere, and then our data port here, we're going to run an extension which is accessible somewhere on the top of the aircraft where you can plug in your data terminal. So really this can go anywhere. The deciding factor is basically the length of that lead going to the turbine itself. So we can pretty much bury it anywhere in this location. So it's going to pair up nicely with the lighting system power as well. All right, so just prepping our data relay module to go inside the aircraft. So I'll give you kind of the layout here. So this is the line that goes to the turbine. You can see here we've got our line going to our pump, which is this servo lead. And then on this side, we've got our data port and our throttle cable. So our throttle cable is just a throttle cable. The data port, we add a Y in here. So the reason for the Y is we've got our telemetry module from our Zyko turbine. And then this is going to be where our screen plugs in. So we're going to put an extension on this portion and have it accessible from the external part of the aircraft. And then the telemetry goes into port number 1 on our E4 expander. The M-speed sensor is also going to plug into port number 2. And then this will plug into the EXT port on the primary receiver. So this is all going to be buried underneath the board. And I've also put in our M-speed sensor right there. We've got our airline going right to the M-speed sensor. And then our line here goes underneath and plugs into our E4 expander. All right, so we got our board installed in there. The mess is kind of hidden underneath. All of our other mess is just sitting on top waiting to be plugged in. And I think we got everything through there. So happy with that so far. These lines here are coming from the front. They're just going to go straight down into their appropriate location. This lead here is the one for our data relay module extension or turbine GSU. But yeah, everything's packed underneath there nice and tight, so it should be good. Once the tank goes in there too, the tank's also going to kind of cover that rear section. So not that it's messy, it just, yeah, it's kind of messy. But anyways, we've got our leads here for our power. Those are going to be tucked underneath right there and run forward. So we've got those set aside, and yeah. So next thing I'm going to focus on is getting the leads all plugged in. Now I'm not going to do this board up yet, although it should go down just fine. You can see there it's bottoming out. We don't have anything underneath the board, and yeah, that should work good. But I'll screw that down once I'm confirmed that everything's run through, and we've got all of our leads through. So just getting everything plugged into the receiver setup here. We've got the 900 plugged in. We're powered through the 900, so not powered through our main power system. And what I was doing here was getting stuff reorganized in the receiver. So I'll show you that first here. So port number 8 on the receiver, we are using as the input for the 900. So what we need to do is we needed to go in and change that on the Rex 12. So we've gone into receiver outputs, output pin number 8. We'll just go here first. Output pin number 8 is set as a backup, which is fine. Well, what that means is output pin number 8, which is supposed to be flaps, we can't obviously use that for flaps anymore, so we have to change that. So then we come into receiver outputs, and pin number 7 was flap 1, which is left flap. So then we went backwards. So pin number 6, we changed to flap number 2, and output pin number 5, we are going to change that to the function we just set up, which is supposed to be lights, servo assignment. There we go. We need to assign that first. Anyways, we made, we'll jump forward here a little bit. So we made a function for lights, put it as logical switch number 2. I'll talk about that in a second. So then we have to go and assign our servo. So that's going to be number 13. We'll assign that as light. That's fine. Need to go back to function assignment. And we've got light there, that's fine. So now we need to go back to model, device explorer, Rex 12, and we need to set our output, which is number 5. That's what it's currently plugged into. We're going to set that to our light, which is 13. So now output pin number 5 on the receiver is using function 13 in the radio. And then I'll show you what I did with the logical switch here. So I went in, we already tied that to the logical switch number 2. So we go to advanced properties, logical switches, created a logical switch called light, and that's got 2 things. So in this case, I want an override on the lights. So I don't want to just have the option to drop the gear and have the light turn on. I want to be able to turn the light on and off if we don't want the light on. Let's say the light's blinding you because it's coming in and these sky candy lights are so bright. Well, that's what the logical switch comes in. So our logical switch is tied to our gear switch, which is SB, and our SC switch. This is generally the switch I use for lighting control. So this is also in an AND condition. So gear needs to be down, this switch needs to be forward for the lights to work. If any of these are changed, so let's say we turn our lights off, our logical switch is no longer active, meaning the lights aren't going to work. If we turn this back on, I've added a 4-second delay, and the reason for that is if we're in a gear up position and we drop the gear, I want the light to come on in about 4 seconds when the gear comes down. That's not necessary, that's just a fun little thing. So if you look here, when I switch the gear switch, you'll see this change slowly over a 4-second period. So it slowly ramps up. Now that slow ramp is a function of that right there. So we can go in and change this to that, which means it'll wait 4 seconds and then go boom. So let's try that again. So we've switched it up, it's off. We're going to switch our gear down. 1, 2, 3, 4, on. Good. There we go. So that has everything set up on our outputs. All right, so just going back into the model here, confirming a couple things. So going into our timer's sensors, sensor logging setup, our M-speed sensor is showing up. I have blown some air into the front here. You don't put your mouth around it, you just blow air into it. And does register our telemetry. The turbine's not working yet because there's no turbine, no power to the turbine, so that's fine, it will pop up there. Now, the next thing we're going to probably work on is putting our engine in, fuel tank in. That stuff's basically ready to go. We do have to check the fuel tank and make sure we're happy with it. But we have to goop the connectors going into the Rex 12, but we do need to leave the EXT port, which is on the Rex 12, accessible. Now when the owner gets this plane, he's going to have to bind it to his radio, and he'll need to pull the plug out of the EXT port down there, put a bind plug in, bind it, and then put that plug back in to the Rex 12. Access to the cortex port is right there, no big deal. Access to the R3. The R3 is our on-off switch, that's right there, no big deal. And then our EXT port on the 900 receiver, the 900 is going to be mounted right here, so there'll be really good access there. So all those things basically are a one-time thing when he gets the plane to bind all those items to his radio. Change of plans on the main receiver. I don't like the idea of having to dig around in there and have the owner do that. So I'm doing up a Y cable. This is just simply exactly what it is, a Y cable. So this is going to plug into the primary receiver. This is going to have our expander plugged into it, so that's fine. So this will still come to one lead, but it'll be externally accessible or more easy to access. Like, we don't need to have it accessible from the outside, but just a lead coming out here so we can actually get to it. So maybe it'll come up to this area right there as an example. So then when the owner goes to bind this, he just needs a Y cable. So battery in one side, bind plug in the other side. That goes to the primary receiver and accomplishes the same thing as what we're trying to do here. So, or you can put a bind plug in this side, put a battery in one of the open ports, but it's a lot easier to just do it from this end with another Y cable. So that is what we're doing on the primary receiver. So just rinse the tank out. The CMJets tank is a great setup. You really don't have to do anything to it. Everything's tie wired. The length is perfect. It drops, the clunk drops right into this little V right here, so it'll absolutely suck up every drop of fuel. So very cool tank setup. Just use rubbing alcohol in here, so put about half a bottle in there, swish it around, put the other half in there, swish it around. A little tank like this, I blow it out with my air compressor, and now it's completely dry. All the dust is rinsed out of it or taken out of it, and we are good to go with it. So tank is now installed using this, this holder that Lewis, the owner, included. Is awesome. Super simple way to get that mounted. Turbine's reinstalled. Cable is originally run up from the ECU or the data relay module, so that's a nice easy plug-in. Fuel line we still need to run from the pump, so things are going together very nicely. We've got all of our goop done as we did previously, so really only a handful of things left to do. Basically, we've got the end to put on our EXT port right here for our primary receiver. This end here we left nice and long. This is our plug-in for our GSU, so we'll figure out where we're putting that. We've got our battery leads here, which are good. So what we need to do now is we need to get our plumbing done. So we're gonna locate our vent fitting, which is probably gonna go right in this area down here. We'll get that kind of fit and run. And we've gotta run our line from the fuel pump back to the turbine. All right, so a couple more updates here. We've got our valve attached, that's all plumbed. Our filter that comes with the turbine is installed right there. So easy access, there's some excess line there to pull that up. Valve's done, turbine's plugged in, fuel vent is run to the vent line. Put a clip on here to clip the two lines together. And I just did a template for our carbon cover. So the carbon cover is going to go right underneath here. It's going to close off this space just like that. And it's going to just make a nice finished look and hide all the mess visibly. Now I'm not sure yet if we're going to put our fuel filler through this or if we want to hide it underneath. I'm thinking about hiding it underneath for a super clean look, but we'll see how it goes. I'm just running the battery lines forward here. I think we're very close to not needing any nose weight. I've put the batteries in the nose here, and it feels pretty good on the nose. Oh, we also added our GSU plug right there as well. So that is where you plug your screen into. It's marked and looks good. So let's get some batteries dealt with in the front here. I'm pretty sure we're going to put those in the front, so we'll start planning for that. Almost ready to test run this thing. All right, so we've got the little cover plate done up here. I was going to put a bunch of screws in there, but I just went with 4 because it's not going to hold anything. So this is just for aesthetics basically. And also decided to put our filler on the side here, so I'm not going to have anything come through our decorative piece. So now we're going to take this thing off. Our film is still on here. That's what I was using. The reason I left it on there is so I could use my white marker. So we'll take this off, take the film off, get our fill line installed on the map, and get that mounted on the side of the fuselage. And also, while we have the plane together here, we got our rudder or vertical stab linkage installed. That's done, covered with shrink tube, and nice and solid. All right, so we got our fill line done here. This goes into 2 of our 6mm Festo clips, which also works for Tygon, and we've got our dry brake port from Jersey Modeler. Also took the liberty of filling up the UAT, so our filter is soaking. Now we're not going to put our panel on here until we're done with our engine run, our programming. Then we'll do our CG at the very end. Batteries are in here, but there's nothing to hold the batteries down yet. So again, we're going to work on that after, but we do have our batteries fully charged, ready to go. So I think the next thing to do, pretty sure, is to test run this engine. So once we do that, then we'll put the plane back on the stand. We'll get all of our throws and everything set up. So let's run this engine. Okay, so we got our plane on the ground. First thing we're going to do is we are going to fill up the plane and measure fuel capacity so we can get that programmed in. We're going to use our custom fuel station from RC Custom 3D Printing. This has the it's an automatic fill station, but it also has a flow meter on there as well too. So it'll tell us exactly how much fuel we are putting in the aircraft. All right, so we've got 1.2 liters of fuel in that tank. So definitely a plane you want to use a taxi tank with, I think. If I had this plane in the setup, that's what I would use. But and we've got a little bit of an air bubble up top there. I just didn't want to go too far to start blowing out fuel out of the vent line. But looks like we are ready to run this aircraft. So we'll turn it on. We're going to get a little bit of the programming done, teach the throttle channel, program the amount of fuel that goes in there, and then we're ready to run it. All right, so we have learned the turbine to the radio. We have also programmed our fuel capacity in the turbine. And last thing I haven't checked here is our data coming up on the screen from our telemetry sensors. So let's look at that. Okay, so we've got M speed, perfect. We've got all of our turbine stuff there, so I'm not going to worry about that because we've got our screen hooked up right now, but we will get all that stuff programmed into the radio. So let's run this thing. Now, we're going to do our typical run with this, this turbine. It hasn't been run yet before, so what we're going to do is we are going to start it, let the idle stabilize, slowly over about 20 seconds, go to max throttle. We're going to let the max throttle stabilize. We're going to check the acceleration. Auto restart has been turned on, so we're going to turn the we're going to try restarting it, and that's what we're going to do for the run up. So let's see how this works. As we go through it, I'll put on the screen what's happening. All right, guys, so ready to run the turbine. Everything's ready to go. So let's start this up. We've primed the fuel system, so it should work good. And yeah, let's give it a go and see what happens. So we do have our GSU installed here. I put a little bit of the telemetry on the screen, so we've got that as well too. We're just going to go through our normal process of letting the idle stabilize. We will do a throttle check, let the max throttle stabilize. I'll put on the screen what's happening while we go through this. Let the idle stabilize. Very good. Engine ran awesome. I think that's going to be a really good amount of fuel in this aircraft. 1.1 liters doesn't sound like a lot, but this engine is so fuel efficient that that tank is a great setup for it. And CG with the Rebels, we are very close. We're going to add a little bit of weight to the nose, I think, but we're very close to where it needs to be. All right, so we're going to turn the aircraft back on. One of the things that we didn't really take a look at before is the landing light. And there it is. Super cool. So we've got a couple things going on here. Number one, we've got the landing light set up on a switch. That switch also works, well, that works with our logic switch, right? So our SC or our gear switch does the same thing. Oops. Sorry guys, that was Nez bumping the camera. So basically if we flick the light switch, which is SC, that turns it off. I'm going to turn it back on right now, and there's a 4-second delay, 2, 3, 4, and the light comes back on. So that works cool. And then if we do gear up, that will make the light turn off as well. So we'll do our gear check here. So we'll turn the light back on. So it'll come on in 4 seconds. Brakes are also very good. They're very adjustable. So when we were doing the engine run there, if we go to half brake, maybe you can hear that buzzing, but very modular on this, this gear set. It's really nice. That's using, of course, the Zycoy controller or the Electron controller. So gear up, and nothing works. We haven't tried this through the controller yet. Oh yeah, there we go. So gears up, gear down, works good. Maybe it's a feature on that controller where you have to do a cycle first. I'm going to power cycle this. So model is shut down. So we're going to turn the model back on and try putting the gear up in C. There you go. Airplane's good. Gear up. So yeah, that's got to be just a function of the controller. Yeah, I increased the channel a little bit as well. Interesting. So there's no programming port on the Electron controller, which is designed for ER40s. So Lewis, when you're watching this, you're going to have to do a gear cycle before you fly the plane. Or if you take off and you forget that, then you got to do a gear cycle twice in the air. But after that, it works perfectly. Nice. So that's cool. Gear works good. Turn that light off. Awesome. So next thing we're going to do is we're going to go through all of our setup. Now the setup on the Rebels is quite simple. Basically, we've got 3 different flight modes. Those flight modes are tied to our flap switch. So we are going to go through and do all those flight modes. Once we're done, I'll show you guys, but the overall, the programming on the Rebels is quite simple and really not a whole lot of craziness going on. The manual kind of gives you a basic outline, but you just got to fly it and go by feel. So I'm going to get this set up to where I think it's going to work great. Some of our adjustments and compensations, and then the owner is going to have to adjust it as he flies it. All right, so I'll take you guys through some of our programming here. So because we use flight modes, we've got 3 different flight modes set up. So those flight modes are tied to our flap switch. So if we go here, they're basically all going to be the same, except we add a little bit more elevator on the full flap mode. So there's full flap mode right there. So when we do it this way, if we make any changes, we got to do it to every flight mode, but there's actually 6 because we also have a gyro off flight mode in each one. So regular flying, gyro on, gyro off. You'll see the expo change there. We change the expo so that it feels more normal or more the same when you turn the gyro off. So we've got that same setup in each of the flight modes, and our elevator has a little bit more travel on full flights. So just a a little note here. So if I do a first flight on an aircraft like this and say, okay, we need to up our ailerons to 70%. So we actually need to do that in all flight modes. So we're going to go in here, we're going to change this to 70%, gyro off, 70%, takeoff flaps, 70%, gyro off, 70%, landing flaps, 70%, gyro, 70%. So there's actually 6 different flight modes to change that on. But because we got flight mode set up, if the owner takes this up and he flies it and he makes some trims in regular flying and in full flaps, all that stuff, it saves it per flight mode. So we've already got some elevator compensation added in here, which is pretty close for full flaps, so that shouldn't need too much adjustment at all. And we've also got some crow put in here as well too with full flaps. So if we take the flaps off and go to landing, crow comes out, and a little bit of our elevator compensation also comes out. So that's programming for this aircraft. Pretty straightforward. It's basically done for the programming end of things. We have some voice announcements set up here as well too. So if we go to full flaps, because we have the pitot tube speed sensor on there, it reads out
miles per hour.
the speed constantly every 3 seconds.
Miles per hour.
That's only in landing
0
flaps.
miles per hour. To flight mode 1.
And we can also add our speed onto the second screen here. So we'll go timers, sensors, displayed telemetry, and we will add telemetry, M speed, single size. And if we go back to that screen, now we've got our speed listed on the bottom. So programming portion for this aircraft to be ready for the maiden flights, that is complete. All right, so we've taken our fuel out of the fuel tank. The map tank, we're going to leave some fuel in there like always. And we've reprogrammed the gyro. So now that we've done all of our setup, that was the time to reprogram the gyro. And I've confirmed all of our surfaces are moving the correct direction. If you're new to Cortex, you got to remember that you're always waiting for the double bump. So when you start your aircraft, hands off, you're waiting for the bump on your surfaces. That means your gyro initializes. So sometimes what happens with these planes is you take it for the first flight, you do a bunch of trimming on it, and the gyro, because it's out of trim, now it won't initialize properly and you have to relearn the gyro. So that's why you need access to the programming port on the gyro, which we do in this case, and just put a bind plug in there, go through the learning process, and it's pretty straightforward. So that's done. So now we're going to put our cover plate back on, now that that's all done, and it's time to finalize our battery installation and get our lighter side of RC placard installed. So the RCCG machine is going to be a very big help on this, this CG check on the Rebel Hot. We've pulled the Rebel Hot wing off. We've measured the leading edge to the back of the wing tube, and it's 185 millimeters. So that is going to give us our numbers for our Zykoy CG unit. But our RCCG machine is going to take care of all the measurements really quick for us. So we want to get this thing put together. Very, very simple to put together. It takes, I don't know, about 2 minutes to put together, if that. And it's going to help us to get this thing CG'd 100% accurately. All right, so there's our final weight, no fuel, UAT full, 13.09 pounds, and our CG is bang on, so 59 millimeters in front of the landing gear, so we are perfect for the CG. I added a couple weights here on this side, and there's one more of the big ones right on this side right here. And that is done. So I think that weight is probably going to come out after the first few flights, but that's just a back of the wing tube setup here. So we've also got our batteries glued in. We used one of our wooden trays. Those are available. I don't know if I've put them on my website yet. We've got the bigger ones, but these ones are designed to hold the smaller, like 2,000, 2,500 milliamp batteries. I don't know if I've got those on the website yet, but anyways, guys, CG, done. All right, guys, and that wraps up the build of the CARF Rebel Hot aircraft. Very cool aircraft. I'm very happy to be able to have put one of these together now, and it's a very impressive little airplane. I'm sure it flies a lot like the Rebel Classic, a lot like the Rebel Pro, obviously just smaller. Pretty slick layout on this one as well too. Obviously lots of different methods and ways to put one of these aircraft together, especially now with the fuel bag approval in the US. That opens up a whole world of options for this aircraft and many other aircraft as well. Guys, don't forget to check out the lighter side of RC After Dark. The After Dark channel is a completely separate channel, and what we do there is we do live streams here from the shop and sometimes from events 2 hours every 2 weeks. It's fun. If you're on during the live stream, the coolest part about it is we get to interact with each other, and I get to see comments from you guys. Very, very cool. So this has been fun. Quick little build. I'm excited for the owner Lewis to get this and see some footage of this thing flying and seeing him put it through its paces. So very cool aircraft. If you guys have any questions or comments, make sure you list them down below. We also have a Boomerang Lancer coming to the shop here as well too, which we're going to build, and very similar size I think to the Rebel Hot here, so that's going to be a fun aircraft to put together. That's my aircraft, and I'm going to be putting a Zykoy X95 in that one, so that should be a hoot. Anyways guys, thanks so much for watching the videos. I truly appreciate it. Also thank you to you channel members. Channel members get to see our videos early. It is a paid thing, but thank you to the channel members that are currently members of the channel, and hopefully you're enjoying watching the videos early. Thanks guys for watching, and we'll see you in the next video.